Problem 62. So a 500-gram steel block rotates on a steel table while attached to a 1.2 meters long hollow tube. So the tube is 1.2 meters and the mass of the block is equals to 500 grams, which is 0.5 kilograms. And then, so there's an air ejected from here and then provides a thrust force of 1.4 newtons. So the thrust force is 4 newtons. So, and then it's perpendicular to the tube. And then the maximum tension the tube can withstand is 50 newtons. And then he's asking if the block starts from a rest, how many revolutions does it make before the tube breaks? So he wants us to find the revolution. So we know the thrust force provides a 4 newtons force and it's perpendicular to the tube. So it's going like this way. So sum of the force in tangential direction equals to mass times the acceleration in tangential, and it equals to, so the tangential is this way, so it's 4 newtons going up, and then minus the friction going here, friction, so it should be mg mu k. And then so we know the mass, and then we know mg, and then mu k is still on a steel, so here is 0.6. So we can find the acceleration in tangential direction equals to 2.114 meters. So since we want to find the revolution in the end, it's better to change the tangential acceleration to the angular acceleration, which is a equals to so this one equals to AT over R, so which equals to 1.762. So we find the angular acceleration, and then the tube breaks at 50 newtons. So it's analyzed in a radial direction. So in radial direction, this one equals to 50 newtons, the maximum, and equals to m. So this is the angular acceleration, and then we know 50 newtons, and then we know radius, and then we know mass, so we can find the angular velocity, which equals to 9. And then this is the maximum velocity at 50 newtons. So we can plug in into the equation for rotation. What final equals to? So we know the final velocity, which is here, and then we start from rest, so angular velocity equal to 0, and then we know the acceleration is here, and then we're trying to find the distance you travel. So we can find out the distance equals to 23.6 by 2 radius. So it's asking for the revolution, so we're going to convert to revolution, which divided by 2 pi. So is 3.762 revolution, and that's the answer.